Hello students, Mr. Madison here with another video key. This video key will be for your practice 2 on the area of circles, which contain 9 problems, and my intent is to just start with number 1, run through and work each problem for you. At the end we'll have then a complete key to this practice. So let's start with number 1. We're asked to find the area of the shaded region. To describe the shaded region, I would say we have a 135-degree sector. So this shape is called a sector, and that shape is going to be a certain fraction of the area of the circle. So to create the fraction, you're going to take the degree measure of that sector, which would be 135, and you're going to divide by 360. And then you're going to multiply that fraction by the area of the circle. The area of the circle would be pi times the radius, which is 20 squared. These answers we are going to get in terms of pi. So you're going to have a pi in your answer. You can go ahead and write that down. And now all we have to do is this arithmetic here. So I'm going to go to my calculator, and I'm going to do 135 times 20 squared. And I'm going to go ahead and hit enter, and then I'm going to divide by 360. And I'm coming up with 150. And don't forget, this is area. Area is always given in square units. So this would be 150 pi square inches. So that's our answer here to problem number 1. Problem number 2, we're again asked to find the area of the shaded region. But you need to understand that the unshaded part of the circle is a 54-degree sector. So what I'm going to do is I'm going to take 360 and subtract 54 to get 306. So this part of the circle that's shaded is really a 306-degree sector. So when I form my fraction here, I want to be careful and do it correctly. My number on top is going to be 306. And once again, that 306 corresponds to the shaded part of the circle. The 54 degrees would correspond to the unshaded part. And then that'll be over 360. And then I'll multiply by the area of the circle, which would be pi times 30 squared. Once again, I can go ahead and just put the pi down. And I'm going to do a calculation. I'm doing 306 times 30 squared. I'm going to hit enter, then come back and divide by 360. And I'm getting 765 pi. And it's going to be, again, square inches. Problem number 3 is different than the first 2 problems. In problem number 3, we're given some information. We're told that the area of the shaded region is 48 pi, but we're asked to find the area of the unshaded region. So think about this for a second. This is 90 degrees. Now 90 out of 360 is 1/4. So I would say that 1/4 of this circle is not shaded. So if 1/4 of the circle is not shaded, then it stands to reason that 3/4 of the circle is shaded. So we're trying to find the area of the unshaded region. That's going to be our answer ultimately. Well, here's what I know. I know that the area of the shaded region is 48 pi. That's given. That would have to equal 3/4 of the area of the whole circle. So if I want to figure out the area of the whole circle here, I would multiply by the reciprocal 4/3 on both sides of this equation. And this A stands for the area of the entire circle. So over here, so let's see, 3 goes once, 3 goes into 48, 16, and then 4 times 16 would be 64 pi. So let me pause for a second, make sure everybody follows what's going on. I just wrote out a little equation, and I said that the area of the shaded region, which is 48 pi, has to equal 3/4 of the area of the entire circle. And then I solved for that. So the area of the entire circle is 64 pi. Now, if the area of the shaded region is 48 pi, if I take 64 pi and I subtract the shaded region, which is 48 pi, then that would have to give me the area of the unshaded region, which would be 16 pi. So in the end here, I just did a little subtraction problem. All right, let's look at problem number 4. In problem number 4, we're told that the area of the shaded region is 81 pi square inches. And we're asked to figure out the degree measure. So I'm just going to write out my formula for the area of a sector. So I know that the area of this shaded region is going to have to equal some fraction, which is x degrees divided by 360, and then I multiply by the area of the circle, which would be pi times the radius squared. So I'm just going to take an algebraic approach here, which means I'm going to substitute into my formula the values I'm given, and then I'm going to solve for what I'm looking for. In this case, it's x. So the area of the shaded region is 81 pi, so I'm going to write that down. And that has to equal this value, this degree measure right here, x, divided by 360, times the area of the circle, which would be pi times 27 squared. So algebraically here, to isolate x, I'm going to divide both sides of this equation by pi. So I'm just very simply going to cross out the pi's. They're gone. Now I'm going to write this 81 down. And to get rid of this 27 squared, to get the x isolated, I'm going to have to multiply by 1 over 27 squared. And to get rid of this 360, I'm going to have to multiply by 360. And that would isolate the x. So when I go to the calculator, here's what I'm going to do. I'm going to do 81 times 360. And I'm going to go ahead and hit enter. Then I'm going to say divided by, and then in my calculator, I'm going to do 27 squared. 27, I'm hitting my x squared button, squared, enter. And I'm coming up with 40 degrees for x. All right, problem number 5. We're told that the area of the shaded region is 195 pi, and we're asked to find x here. Well, here's what you need to understand. This shaded region here, when I put my number on top of the 360, it's going to be whatever x is subtracted from 360. So I'm just going to make a numerical example. If x was 60 degrees, then the shaded part would have to be 300. So I'm going to write down my formula again. The area of the shaded region would equal the degree measure of the sector divided by 360 times pi times the radius squared. Now, this degree measure that you put on top here has to correspond to the shaded region. Now, the shaded region is 195 pi. This shaded region has a degree measure that will be equal to 360 minus x. I can't just put x on top here because x corresponds to the unshaded region, and the 195 pi is the area of the shaded region. So the degree measure on top would be 360 minus x. And if there's anything tricky about this problem, that would be it. That's why I'm spending so much time talking about your numerator in this fraction. It needs to be 360 minus x, which would be the degree measure of the shaded region. So over 360 times pi times the radius, which is 15 squared. Now we're going to let our algebra kick in. The pi's would cancel here. I'm going to write down that 195. To get rid of this 15 squared, I'm going to multiply by 1 over 15 squared. To get rid of this 360, I'm going to multiply by 360. And that would isolate that expression in the numerator, which is 360 minus x. So I'm going to do this calculation. I'm doing 195 times 360. I'm going to do it in steps. I'm going to do enter, then divided by 15 squared, enter. And I'm coming up with 312 is equal to 360 minus x. And then to solve for x here, I'm just going to switch places between the 312 and the x. And what I'm saying is that if 312 is equal to 360 minus x, then x would have to equal 360 minus 312. And I think that 360 minus 312 would be 48 degrees. All right, let's go on to number 6. In number 6, we're told that the area of the shaded region is 160 pi, but we're asked to solve for r. So once again, I'm going to take an algebraic approach. I'm going to write down my formula. Area of the shaded region, which is a sector, has to equal x degrees over 360 times pi times the radius squared. Time to substitute. For the area of the shaded region, I'm putting in 160 pi For x, I'm putting in 144 times pi, and then it's the radius we're looking for here. So all I could do is write down r squared, because I don't know what r is. Okay, the pi's would cancel. I'm going to write down this 160. Now to get rid of the 144 over 360, I'll multiply by the reciprocal, 360 over 144. And that would isolate the r squared. So I'm going to do this calculation. I'm doing 160 times 360 divided by 144. I'm getting 400. 400 is equal to r squared. Now the last algebraic maneuver here to isolate r would be to take the square root of both sides. And the square root of 400 would be 20. So the radius for this circle would be 20 inches. All right. In problem number 7, we're again asked to find the radius. We need to be careful, though, because we're given the area of the shaded part of the circle. But this 35 degrees is the unshaded part. So to figure the degree measure of the shaded part, I'm just going to do 360 minus 35, and I'm going to get 325. So when I do my formula, here, I'm going to write out my arc length, my sector, area of a sector formula. So the area of the shaded region here is going to equal x over 360 times pi r squared. The area of the shaded region is given as 520 pi. But the degree measure that goes with that shaded region is not 35, but rather 325. So I'm going to have 325 over 360 times pi times the radius squared. Solving, the pi's cancel. I'm going to write down this 520. To eliminate the fraction here, I'll multiply by its reciprocal, which would be 360 over 325. And that would isolate the r squared. Doing the calculation, I'm doing 520 times 360 divided by 325, and I'm coming up with 576 is equal to r squared. To isolate r, however, I need to take the square root. And the square root of 576 is going to be, I believe, 24. Want to make sure here, so yeah, it's 24. And we're done. So the radius of this particular circle then would be 24 inches. All right, let's look at number 8. Number 8 looks unique. We're asked to find the area of the shaded region. Well, we have one sector here that is a 60-degree sector. We have an unshaded sector that's 100 degrees. And then we have another sector here that is not labeled with any degree measure. But let's be smart about this. This line segment is a diameter, which effectively cuts the circle into two 180-degree semicircles. So I know that from this point all the way around to here would be 180. So if this is 60 and this unshaded is 100, then this smaller sector right here has to be a 20-degree sector. So when I go to find the area of the shaded part, I have a 20-degree and it's 60-degree, which I'm just going to combine into an 80-degree sector. Once again, let me explain where that 80 comes from. The 80 is the sum of the 60-degree shaded sector and the 20-degree shaded sector. How did we get the 20? Well, we realized that this was half the circle here. Half the circle is 180. If two parts are 60 and 100, then the third part has to be 20. So I'm going to multiply that fraction by the area of the circle, which would be pi times the radius, which is 45 squared. So all I have to do is this calculation. I'm going to go ahead and put the pi down. I'm going to do, on my calculator, 80 times 45 squared, enter, divided by 360, and I'm coming up with a pretty big number, 450. I'm going to do a check on that just to make sure I did it right. I believe that I did, but 80 times 45 squared divided by 360 is 450 pi. So that's our answer. And this would be square inches. All right, one more to do. Let's look at number 9. We know that the area of the shaded region is pi, and we're asked to find the area of the unshaded region. Well, this problem is similar to problem number 3. It's a little different. It's not really difficult at all. It just makes you think a little bit. Here's what we know. We know that 120 degrees out of 360 would be 1/3. So the shaded region is 1/3. So it stands to reason then that the unshaded region for this circle would have to be 2/3. So let's think about this. The area of the shaded region is pi. So I know that if I take 1/3 and multiply by the area of the entire circle, I will get pi. So the area of the shaded region is pi. And that has to equal 1/3 of the area of the entire circle. Well, if the area of 1/3 is pi, then the entire circle would have to be 3 pi. If I multiply both sides of this equation by 3, then the area of the entire circle would be 3 pi. And if the area of the shaded is pi, then the area of the unshaded would have to be 2 pi. Another way to maybe state it would be this. If 1/3 of the circle is pi, then 2/3 of the circle has to be 2 pi. So that's our answer here, 2 pi square inches. So there you have it. There's a key for you to practice number 2. I am hopeful that my demonstrations were easy for you to follow, and that the key here is helpful for you. You would expect your quiz, your first quiz on area of circles, to post today. Thank you for your attention. You all have a great day.